in this video will test your knowledge of organic chemistry thus far, and maybe you could kind of use this as some sort of studying tool for your final. And definitely they probably won't give you anything on your final of this nature, but again, the main purpose of this kind of exercise is to test what you've learned so far, and can you predict the products? Do you know what the reagents are for? Do you remember what they are for? So before I kind of delve into it, kind of draw the synthesis out and do it yourself, and then come back and then see how I solve it, to kind of see what's going on. All right, so let's get into it. All right, so I'm looking at an aldehyde here, and I get to a secondary alcohol. Right now, the first thing I look to see if my carbon chain is extended. So again, I have a CH3 here. I have a hydrogen here, so that means my carbon chain has been extended by one. I've created an alcohol. The only current way we know to create carbon-carbon double bonds as of now is using Grignard chemistry. So that's what I'm thinking of. Now my carbon chain is extended by one. So that means I could use methyl bromide in H3O plus, some sort of acid. Right? I could use methyl bromide in some sort of acid. Right? Right, and remember we said in Grignard chemistry, all this does is that attacks the ketone, right? Attacks the ketone, it should be magnesium bromide. So methyl magnesium bromide. So maybe I should have my magnesium bromide here. All right, and all this does is it attacks my ketone and form that CH3, and then the hydrogen comes in the last place to give me my alcohol. So methyl magnesium bromide in some sort of acid will be the answer for A. Now, I see that I have a secondary alcohol here, and I got to a ketone. Well, remember we talked about the oxidizing agents, right? So Jones or PCC will work in this case, all right? Because remember we said Jones and PCC, these oxidizes secondary alcohols to ketones. So in this case, either of these oxidizing agents will work. Now I have my product C, and I got to this here. So what are the reagents? Well, I see that my carbon chain is extended. All right, my carbon chain is extended. So that's what I'm looking for. That's the first thing I'm looking for. I have a ketone. So that means, and I form an alcohol, right? So that means this has to go through some sort of Grignard chemistry. So maybe if I add, the cyclic molecule here bonded to magnesium bromide, right, in some sort of acid in the second step, this will give me my indeed product. All right, again, we have a ketone. This carbon here is nucleophilic, so this will attack my ketone. Slightly electrophilic carbon, right? Kicks off the double bond on oxygen, and water comes in the second step to give me my alcohol. All right. So again, Grignard chemistry. Now I have D right here. I have this molecule here, and I got to this. So what would be the reagents? Well, this one is a tricky one. You got to think about it. I have an alcohol. The alcohol disappeared, and I form a alkene carbon-carbon double bond, kind of on the less substituted part of the carbon chain, right? So again, I'm thinking of some sort of TBUTOX here. Does that come to your mind? This has to be some sort of TBUTOX, but remember, our alcohols are super hard leaving groups. So remember, we've learned about protecting groups. So I could have actually had TSL here in some sort of mild base, as we said, and protect my alcohol. Now my alcohol is protected, I could add TBUTOX in the second step. Right, and remember we said TBUTOX goes for the most accessible hydrogen. So once TBUTOX comes in, it's looking for these methyl protons here. So it comes in, take off one of these protons, form the double bond, kicks off the now tosylate, right? It's not OH anymore. And this is actually a great leaving group. So this will be the reagents we will use to get to this product. Now I'm taking a look at this product and we got to an alcohol, right? So immediately I'm going to an alcohol. What am I thinking? Well, again, look at the substitution pattern for your carbon-carbon double bond. I have an alcohol on the less substituted part of the carbon-carbon double bond, right? So what does that tell you? This is simply hydroboration. And THF in the first step. And in the second step, you're going to add sodium hydroxide and hydrogen peroxide. All right. And these reagents will give me this product that you see here. Again, my alcohol is on the less substituted part of the carbon-carbon double bond. All right, 2 hydrogens here, no hydrogens here. There's my hydrogen, and there's my OH, so H2O. All right, so now I'm looking at this alcohol here, and we got to this product here. Well, again, this is direct oxidation. And remember the special reagent we learned for direct oxidation, and this is pyridium tribromide, PBr3, and this just directly kicks off our alcohol, and we get the bromine on the carbon there. All right, so now we have this product here. We want to see how do we get from here to here. Well, again, I'm looking to see if my carbon chain is extended. I've created an alcohol, so therefore this has to be some sort of Grignard chemistry. All right, so maybe I could use this as my reactant. All right, so maybe I could add magnesium in the first step to create my Grignard reagent, and then in the second step I may add formaldehyde. All right, so I may add formaldehyde. All right, so I may add formaldehyde in the second step. All right, and in the third step, I'll add some sort of acid. Yes. And this will give me my desired product. All right. So now we have this here, and I'm saying what reagent should I use to get to H? To get to what reagent should we use to get to the product here? Well, again, I'm looking at some sort of, I see that I have a primary alcohol and I've created an aldehyde. Well, we've learned about oxidation, right? And we said that PCC is a reagent we actually use. And when we use PCC on primary alcohols, we get aldehydes from them. All right. So this synthesis here tests your whole knowledge, especially in Chem 1. All right. So this is very important. Make sure you're able to kind of do these problems without kind of referring back. Kind of use this as a practice. As I'm sure some of these same problems will probably pop up in your exam or something similar to that nature.